By the way, if you look on PowerSchool, if you download 8.3b extra work, that's actually like you can take notes on this. I have a kind of like that graph paper on the like looks kind of like this, where it's got the problems all ready for you to put your notes on. So if you want to get that, that'd be good. You don't have to. You can just use graph paper to do it. So first thing you want to see is definitely the numerator, the denominator can be factored here. So x plus 2 divided by x plus 2 times x minus 2. And definitely that is going to cancel. When you cancel, you're going to leave a 1 behind. So we end up getting the function is, the new function is f of x equals 1 over x minus 2. So that's my function now, but when I canceled, it causes a hole. So the hole, we know the x value of the hole is at -2 there because I canceled out that negative. That would be a -2 would make that equal to 0. So I know it's -2. If I plug in a -2 there, I get -1/4. If I plug it in for x right there. The vertical asymptote is what's left over. So instead of causing a hole at -2, it causes, instead of causing a vertical asymptote there, it causes a hole. So that is not a vertical asymptote at -2. However, this denominator at x equals 2, always say the equation of the asymptote. So I wrote it over there, so I don't have to write it over here, but you could also write it over here, x equals 2. -2 comma -1/4 is right down here. There's like a little open circle right there. Then the horizontal asymptote, it looks like it's bottom heavy, so y equals 0. So y equals 0. X-intercept, plug in, well, I like y-intercept first. Plug in y, x equals 0, so y would equal -1/2. So I just plugged in a 0 right there for x. So -1/2 looks like right here. And the x-intercept, plug in 0 for 1. It seems like we did this problem yesterday. It sounds familiar. There is no x-intercept, which makes sense because 0 doesn't equal 1. Also because it's an asymptote right there. So it looks like your graph's going to approach, the graph's going to hop right over the top of that hole and then approach the asymptote over here. And then I'm not sure over there if the graph either looks like this or like this. Those are the two options on the right. I guess it looks like that. Let's test a value, like let's test 3. So if I plug in 3 for x, what do I get for y? I get 1 over 3 minus 2, which is 1. 3, 1. Okay, so yeah, it definitely does look something like that roughly. Goes through that point at 3, 1. Okay, let's try the next one. So this one again, if you see some factoring that can be done, that's be the first thing you want to do. So the numerator doesn't really factor there. It's x squared plus 1. The denominator is difference of squares, so that'd be x plus 1 times x minus 1. So it does look like there are two vertical asymptotes, one x equals 1 and one x equals -1. Those are dotted vertical lines. There is no hole, nothing cancels. Same degree, so the coefficients are 1 and 1. So 1 divided by 1 is y equals 1. Horizontal asymptote here. Find the y-intercept, so that's easy. Just plug in 0 for x, and that'd be 1 over -1, which is -1. Find the x-intercepts, so you're going to say 0 equals the numerator, which is x squared plus 1. Denominator will go away. So x squared equals -1, so square root of both sides. Don't forget plus or minus. X equals plus or minus I. Well, I can't graph I on here, so it doesn't cross the x-axis. We know that. So it can't kind of go up here because it doesn't cross the x-axis. So the only place for it to go in the middle is down. It can't be down here because it would have to cross the x-axis at some point there. So it's got to be on the up on the right side. particularly these have little arrows. And same thing here, it can't cross through the x-axis at all, so it's really got to be up in this case, over here. So there is no x-intercept. I should probably mention that. Okay, this one does look like something cancels. So when it cancels, it calls a hole at 4. My new function is f of x equals x minus 2. So if I plug in a 4 there, 4 minus 2 is 2. So 4 comma 2, there's a little hole at 4 comma 2. A little hole in the graph. And there is no asymptote, actually. So there's not an asymptote. So this is just linear, right? This is like 1x minus 2. So y-intercept of 2. Oh, negative 2, yeah. So, yeah, this works. Okay, wasn't sure. So I'm going to go through with the slope of 1 here. Looks something like this. Goes through that little hole. So it doesn't really have an asymptote. It's top heavy technically, right? There's no denominator, 1. So it's just a graph that has a hole at 4, 2. So there's no vertical asymptote. There's no horizontal asymptote. There is an x-intercept at 2. I guess I could have graphed that first, and there is a y-intercept at negative 2. I guess I saw it was linear, so I just went ahead and graphed it because we know how to graph linear, but probably should have just done the x and y-intercept the way we normally do. This one looks like it does have a vertical asymptote at x equals 3. Horizontal asymptote at, there is no hole. Nothing cancels. Y equals 0 because it is top heavy, bottom heavy. Looks like this. Plug in 0 for x, so I'll give you y-intercept of 2/3. Okay, somewhere right around there. And x-intercept would be 0 equals for y. Negative 2 is the numerator. That's not true, so there's no x-intercept. So we know on the left it kind of does this. Goes through that point, approaches the asymptotes. On the right, I need to plug in a point like 4. If I do that, I get negative 2 over 1, which is negative 2, so 4, negative 2. So on the left, on the right there, it does go down. It never approaches that asymptote right there. Ooh, so this one is sneaky. So I think we might be able to cancel. These are just so close. If I just pull a negative out of the numerator, it would make this negative 2 plus x over x minus 2, which, by the way, is pretty much the same thing. So I end up getting 1 is left behind here. So negative 1 over 1, which is negative 1. So f of x, or y equals negative 1. So it does have a hole. If I make the numerator 2, the y value, of course, is negative 1 there. So there is no asymptotes, really. If I plug in 0 for x, that would be 2 over negative 2, which is negative 1. So it definitely crosses down here. If a hole here, there's an open circle there. And the x-intercept, let's see, 0, nothing. If you plug in 0 equals negative 1, like that's not true. So it doesn't really have one of those. So it really is just a graph that looks kind of like this. And this one, well, let's just see if it does cancel. I like to factor stuff and sometimes, stuff will cancel. In this case, I don't think it did, but it's something to try. So x equals negative 1. Negative 1, there's a negative there. There you go. It seems to be, oh, I know why we need that 2 there. So the coefficients are 2 over 1. So y equals 2 because it's the same degree. Doesn't seem to have a hole. Y-intercept, if I plug in 0, I get negative 2 over 1 is negative 2. That's my y-intercept. Plug in 0 for x. The numerator is 2x minus 2, so 2x equals 2, so x equals 1. Right there, so the graph is definitely connected there. Looks like it's definitely approaching the asymptote as it goes down. It's kind of going that way. I don't know what's happening over here. It doesn't touch the x-axis. Wow, that's really weird. It's not like it's weird. Let's plug in a couple points here. So let's do -2 and -4. I have no idea what's happening here. Maybe I made a mistake. So we're going to plug in -2 for x. That'd be -4 minus 2 is -6 divided by -1, which is +6. So -2, 6 is right up there. -4 would be -8 minus 2 is -10 over -3, which is +10 thirds. 10 thirds is like 3 1/3. So -4, 3 1/3, right about there-ish, somewhere in that range. I know those two are connected. I guess we could plug in some more. It doesn't cross the x-axis. So I'm guessing it kind of goes up here, approaches the asymptote, that continues there. And maybe this just kind of like curves up or something. Let's look at this. Well, this is not at all what I expected here. Hilarious. So I forgot to draw the horizontal asymptote there. So that should be like that. So it does kind of do that. It does kind of approach that at 2. And this definitely, now that I know there's a horizontal asymptote there, it's definitely going to be approaching that horizontal asymptote. So the graph might look something like this. I knew I did something there because it's like, it didn't make sense. It's got to be approaching asymptote or something. So when you write down your horizontal asymptote, go ahead and graph it so you don't forget this is not a problem that doesn't have one. It actually has one. This one does seem to cancel, so we get a hole at 2. Let's rewrite the function and plug it in to see what the y value is. So this would be x plus 3 over x plus 1. So that'd be 2 plus 3 is 5. 2 plus 1 is 5 over 3, so 5 thirds. 5 thirds. So 2 comma 5 thirds is right in there-ish. Vertical asymptote at x equals -1. So when it's a hole, it doesn't cause a vertical asymptote. And it's same degree, so it's going to be leading coefficients of 1, so y equals 1. So I'm going to draw in the horizontal asymptote this time. Helps. So y equals 1. And the y-intercept, plug in x equals 0, so that'd be 3 over 1 is 3. So right there. The x-intercept would be 0 equals x plus 3, which is the numerator, so x equals -3. There you go. Oh, I know exactly where this graph is now, right? Hops over that point. It's a point of discontinuity. There you go. Okay, so if you see some factoring, please do it. So x times x squared minus 4. Oh, wow, that factors even more. So this function is going to be f of x equals 4x in the numerator, x times x minus 2 times x plus 2. And let's see what cancels there. So the x's cancel. So there's going to be a hole at 0. If I plug that in, I get 4 over -4, which is -1. So 0, -1, there's a hole. Vertical asymptote at x equals 2 and x equals -2. Horizontal asymptote, it's bottom heavy, so y equals 0. Okay, let's see. So plug in here. So for 0, we get -4 on the bottom. 4 over -4 is -1. Oh, wait, we already got that. We already have a hole there, so we don't need like a point. There's no point there. It's just a hole. Plug in the x-intercept, so that would be 0 equals 4, which is no x-intercept, which makes sense in the context. So looks like the graph's going to kind of go up, go through that hole. Let's plug in a value like 3. See what we get for the y value here. So we get 3 minus 2 is 1, 3 plus 2 is 5, 1 times 5 is 5, 4/5. Big key is it's positive, so it's going to go through top part here. Maybe plug in -3. We get -5 times -1, which is +5, so we get 4/5. Positive still, I think. Something like this. And that's it. Just lots and lots of practice. Sorry about that. Lots and lots of practice for graphing rational functions. Hopefully you're getting better at it. I guess I should have said there's no x-intercept here, and the y-intercept is also not there because that's a hole. That's the only reason.